deterioration of materials by the chemical reaction with the environment. It is a natural process. Usually, corrosion is known as rust, as it shortens the life and damages the beauty and the luster of the object. Both the type of metal and the environmental conditions determine the rate of deterioration. Marine corrosion will damage the structures such as boats, vessels, harbour and ports, and many more. Some examples of marine corrosion are galvanic corrosion, electrolytic corrosion, atmospheric corrosion, and fretting. Galvanic corrosion is induced when a difference exists in the electrical potential of different metals that are coupled together and immersed in an electrolyte, such as salt water. The corrosion process is akin to the simple direct current cell, in which the more active metal becomes the anode and corrodes, while the less active metal becomes the cathode and is protected. The corrosion of these structures can result in premature failures, reduced service life, increased maintenance costs, and safety hazards. Prevention is always better than cure, as effective prevention system begins in the design stage with proper understanding of the environmental condition and metal properties. As a deduction, corrosion should be controlled. In this video, we will introduce you corrosion control method. We recommended cathodic protection, which consists of sacrificial anode and ICCP.
So, when it comes to corrosion, cathodic protection is a method of corrosion control that can be applied to buried and submerged metallic structures. The material to be protected is applied with an external cathodic current, and it can said to be completely protected when it reaches the protection potential. One of the methods of doing this is by using ICCP. So, what is ICCP? ICCP is basically referred to impressed current cathodic protection, where a system used to control the corrosion using anodes connected to a DC power source. And this works on the principle that current flowing onto any metal shifts its normal potential in the negative direction, and a correct amount of current is impressed on the surface to be protected. The potential of the surface can be shifted sufficiently to a level where the surface will not corrode.
Okay, so I'll continue with a brief explanation on sacrificial anode and with a simple comparison between impressed current cathodic protection and sacrificial anode system. So in our previous discussion, we know that there are two different types of cathodic protection system, which is sacrificial anode and ICCP. Sacrificial anode system are also termed as galvanic anode system, which use a metal that is naturally more negative than the metal being protected, and thus when two metals are connected electrically to each other, current flow from the metal which is more electrically negative to the metal which is more electrically positive. The current flow results in a rapid consumption of anode. Hence, the common term sacrificial anode is often used to describe this anode system. Typical galvanic anode include magnesium, zinc, and aluminium, as each of these are more electrically negative than carbon steel and other steel. As mentioned before, impressed current cathodic protection system are different than galvanic system because they utilize an external DC power supply to create electrical current flow. And what are the difference between these two? The advantage of sacrificial anode system is obviously that it doesn't require any external electrical power. Then there's a lot more advantage, and one of it is that anodes are easier to install. On the other hand, for ICCP, it has longer lifespan of anode, higher current system, greater system control, and they are also more easier to control. To use a scenario as an example, to choose which cathodic protection system to use on a hull actually depends. If ICCP system is used, then the hull would have less drag force, lower cost for long-term operation, no risk of damaging internal fan system, and it is fully automatic. If anode sacrificial system is used, it is more simple to install, it has lower cost for short-term operation, and it is available worldwide.
ICCP works by taking electric current from ship power supply unit and impress into whole hull through inert anode that strategically placed on ship hull. Then through the seawater, the current flow back to the ship hull. This can ensure a strong dielectric coating formed on the hull that adjacent to the anode. Meanwhile, the reference cells are used to monitor the potential level at critical location of the hull. They provide feedback to monitoring panel which regulate the output current to the anode. The ICCP system will adapt to the environment such as the pH value, which influence the cathodic current demand by regulating the anode output current to maintain the hull polarization to designated set potential. In design of ICCP system, many criteria need to be considered. Firstly, the material selection of anode is important to form an effective cathodic protection. Inert materials such as graphite, silicon cast iron, but in marine industry, usually platinized titanium. Besides, the arrangement of anode reference cells are also important. They are usually placed on localized hull area such as stern area with complex hull structure, rudder, struts and propeller which require extra protection. Furthermore, the current and the potential and current density required for ICCP system. For example, in normal seawater, the ICCP system set the cathodic potential level at range of negative 0.8 voltage to 0.85 voltage with respect to the silver chloride reference anode, which sufficient to protect the steel structure. The current density required to protect the steel structure in seawater is between 0.05 to 0.15 ampere per meter square.